September 1940, Washington, D.C. Henry J. Kaiser sits in the office of the US Maritime Commission, listening to Admiral Emory Land explain why Kaiser's company will not be awarded contracts to build merchant ships for the British. "Mr. Kaiser," Admiral Land says, his voice dripping with professional disdain, "you have no shipbuilding experience. None. Your company builds dams, bridges, roads. You've never built a ship in your life. The British need 60 cargo vessels immediately. We cannot entrust this contract to someone who doesn't understand shipbuilding." Kaiser, 58 years old, self-made industrialist, builder of the Hoover Dam and the Grand Coulee Dam, leans back in his chair. He's accustomed to being told things are impossible. He's built a career proving experts wrong. "Admiral, with respect, I understand construction. Ships are constructed, aren't they? Steel, welding, assembly. My company moves earth and pours concrete faster than anyone in America. I believe we can build ships faster than anyone too." "Mr. Kaiser, shipbuilding is not dam construction. It's a craft, a tradition. It takes 18 months to build a proper cargo vessel, and that's with experienced shipwrights, master riveters, skilled workers who've spent years learning the trade. You can't just hire construction workers and expect them to build ships." "Why not?" Kaiser asks. The Admiral stares at him as if he suggested building ships from paper. Because shipbuilding doesn't work that way. It's always been done by skilled craftsmen using traditional methods. Riveting, hand fitting, careful inspection. You can't mass-produce ships like automobiles. "Has anyone tried?" Kaiser persists. "Mr. Kaiser, I'm terminating this meeting. The British contracts will go to established shipyards. Todd Shipyards, Bethlehem Steel, companies with decades of experience. Good day." Kaiser leaves the Maritime Commission office without a contract, but he doesn't leave without an idea. If traditional shipbuilding takes 18 months, and America is about to enter a war where ships will be sunk faster than they can be replaced, then traditional shipbuilding will lose the war. Someone needs to build ships differently. Someone needs to build ships impossibly fast. September 1940. Kaiser's office, Oakland, California. Henry Kaiser assembles his top engineers, Chad Calhoun, Bill Waste, Clay Bedford. These are the men who built the Hoover Dam ahead of schedule and under budget. Men who solve impossible problems through unconventional thinking. "Gentlemen," Kaiser begins, "the Maritime Commission just rejected our bid to build British cargo ships. They say we don't know shipbuilding. They're right, we don't. But I've been thinking, what if not knowing shipbuilding is an advantage?" His engineers exchange glances. This is vintage Kaiser, turning disadvantage into opportunity. "Traditional shipbuilding," Kaiser continues, "uses methods that haven't changed in a century. Riveting, hand fitting, one ship at a time, built from keel up by craftsmen. It takes 18 months because that's how it's always been done. But nobody has tried to build ships the way we build dams, with mass production, modular construction, and industrial assembly." "Boss," Calhoun interrupts, "ships aren't dams. They move, they flex, they face completely different stress loads. You can't just—" "Can't?" Kaiser smiles. "Chad, how many times did people tell us we couldn't build Hoover Dam? That the Colorado River was too powerful, the canyon too deep, the timeline too short. We did it by ignoring how it had always been done and figuring out how it should be done." He spreads ship design drawings across his desk. Standard maritime cargo vessel, 441 feet long, 57 feet wide, 10,000 tons deadweight capacity. The British need these ships. They're calling them Ocean Class. Simple design, cargo capacity over speed. They need 60 vessels immediately and hundreds more after that. Traditional yards say 18 months per ship. At that rate, Germany's U-boats will sink them faster than we can build them. "What if," Kaiser asks slowly, "we could build them in 6 months, 3 months, 1 month?" "1 month?" Waste laughs. "Boss, I love your optimism, but that's physically impossible. Even if you could prefabricate sections, which traditional shipbuilders say you can't, you'd still need skilled workers for final assembly. Where would you find them? There aren't enough trained shipbuilders in America to staff that kind of operation." "Then we train new ones," Kaiser says simply. "Housewives, farmers, shop clerks, people who've never seen a ship. We break down shipbuilding into simple, repeatable tasks that semi-skilled workers can learn in days. Assembly line production, like Ford did with automobiles. Bedford shakes his head. The Maritime Commission will never approve it. Shipbuilding unions will fight it. Naval architects will say it's unsafe. You're talking about fundamentally changing an industry that's hundreds of years old. I know, Kaiser grins. That's exactly why it will work. The old way can't win this war. We need a new way. And since nobody will give us contracts to prove it, we'll prove it first, then get the contracts. How? We're going to build a shipyard. Not a traditional shipyard, an industrial production facility that happens to produce ships. And we're going to demonstrate that ships can be mass-produced, like any other manufactured product. His engineers are silent. They've learned that when Henry Kaiser gets this look, impossible things are about to become possible. One more thing, Kaiser adds. When we prove this works, I want to build these ships so fast that the entire world has to rewrite their understanding of industrial production. Not 18 months, not 6 months. I want these ships rolling out of our yards in weeks. How fast are we talking? Calhoun asks. Kaiser thinks for a moment. 30 days, 1 month from keel laying to launch. Boss, that's impossible, Kaiser finishes. Good, I like impossible. Gives us something to aim for. December 1940, Richmond, California. Kaiser breaks ground on Richmond Shipyard No. 1. The site is mudflats, marshland on San Francisco Bay, considered worthless for industrial development. It's perfect for Kaiser's purposes, cheap, available, and close to Oakland, where he can source materials and workers. Traditional shipyards have massive infrastructure, permanent slipways, steel frameworks, sophisticated equipment built up over decades. Kaiser doesn't have time for that. We're building a factory, not a shipyard, he tells his construction crews. Think automobile assembly plant, not naval tradition. Within 3 months, Richmond Yard No. 1 is operational. 6 building ways, each capable of constructing a ship simultaneously. But the revolutionary part isn't the slipways. It's what happens before the ship reaches them. Boss, Bedford reports, we've laid out the prefabrication plan. Instead of building the ship on the slipway from scratch, we're breaking it into 250 major sections. Each section gets built in a dedicated shop. One shop just makes double-bottom sections, another makes bow sections, another does deck houses, assembly line style. Workers specialize in one type of section, Calhoun adds. A welder might spend all day welding the same joint on bow sections. Repetitive work, but that means they get extremely good at that specific task. Quality improves through repetition. And speed? Kaiser asks. Should be significantly faster than traditional methods. Instead of craftsmen fitting each piece individually on the ship, we're having semi-skilled workers build identical sections in shops, then assembling the sections like building blocks. Good, but not good enough. What's our current timeline estimate? 6 months per ship, maybe 5 if everything goes perfectly. Kaiser frowns. Not fast enough. U-boats are sinking Allied ships at horrific rates. Britain is being strangled by supply shortages. We need to build faster than Germany can sink. 5 months isn't adequate. Boss, 5 months would be revolutionary. Traditional yards take 18 months. I don't care about revolutionary, Kaiser interrupts. I care about adequate for winning the war. Keep optimizing. I want 30 days. 1 ship per month per building way. 6 ways means 6 ships per month from this 1 yard. His engineers think he's insane. 6 ships per month from a single yard? The entire US shipbuilding industry is producing about 3 ships per month across all yards combined. But they've learned not to bet against Henry Kaiser. April 1941. First ship launch. The first Ocean-class cargo ship, built for the British Ministry of War Transport, slides down the ways at Richmond Shipyard. Construction time? 245 days, about 8 months. It's not the 30 days Kaiser wanted, but it's less than half the traditional 18-month timeline, and it's the first ship built using mass production prefabrication methods. Admiral Land attends the launch. He inspects the vessel carefully, looking for flaws, expecting to find evidence that Kaiser's radical methods produced inferior ships. He finds none. The ship is sound, structurally solid, properly welded, all systems functional. It's not beautiful by traditional shipbuilding standards. The welds are visible, the finish is utilitarian. The craftsmanship is obviously different from hand-built vessels. But it works. Mr. Kaiser, Land admits grudgingly, your vessel passes inspection. It's adequate. Kaiser smiles. Adequate is exactly what he's aiming for. Not beautiful, not perfect, just adequate and fast. Admiral, how long until we get more contracts? I'll recommend approval for additional British orders. But Mr. Kaiser, I must emphasize, 8 months is good, but Britain needs ships faster. Can you reduce the timeline further? I can, Kaiser promises. This first ship was a learning process. Every ship teaches us something. Watch what we do with the next one. The next ship takes 196 days. The one after that, 152 days. Then 112 days. Then 85 days. With each ship, Kaiser's teams identify inefficiencies, optimize processes, improve workflows. Prefabrication sections get better designed. Workers get more skilled through repetition. Bottlenecks get eliminated. December 7, 1941. Pearl Harbor is attacked. America enters the war. Suddenly, Henry Kaiser's impossible shipbuilding methods are desperately needed. January 1942, Washington, D.C. Admiral Land summons Henry Kaiser to an emergency meeting. The tone has changed dramatically. 3 months ago, the Maritime Commission was skeptical of Kaiser's methods. Now they're desperate. Mr. Kaiser, America is at war. German U-boats are sinking Allied shipping faster than we can replace it. In 1941, we lost 4.3 million tons of shipping, over 1,200 ships. At current production rates, we're building maybe 100 ships per year across all American yards. We're losing 12 ships for every one we build. The British Ocean-class design you've been building, we're adapting it for American mass production. We're calling it the Liberty ship. It's a simplified emergency cargo vessel, 441 feet long, 10,000-ton capacity, 11 knot speed. Not fast, not fancy, but simple enough to mass produce. Land spreads drawings across the conference table. The Liberty ship is deliberately unsophisticated, reciprocating steam engine instead of turbines, slower but simpler. Riveted and welded construction, faster than all riveted. Minimal complexity, easier to build with semi-skilled labor. We need 2,700 Liberty ships, Land states, minimum, to replace losses and build up supply capacity for the invasions we're planning. At traditional production rates, 18 months per ship, we'd need 40 years to build them. We have maybe 3 years before we need them all operational. Kaiser does the math instantly. You need 1 ship per day, every single day, for 3 years. Correct, which is impossible, but necessary. What can you do? Kaiser considers. Richmond Yard No. 1 is now completing ships in about 70 days, 2 months. Revolutionary compared to traditional methods, but nowhere near adequate for winning the war. Admiral, I can build more yards, expand Richmond, add building ways, add prefabrication shops, scale the entire operation. How many ships can you produce? Give me 6 months to scale up and I'll show you. But I need commitments, guaranteed contracts, priority for steel allocation, labour recruitment support, suspension of traditional shipbuilding regulations that slow production. You'll have everything you need, Land promises. But Mr. Kaiser, I'm authorising Liberty ship contracts to 18 different shipyards across the country, not just yours. Even with everyone building as fast as possible, we're going to struggle to meet production targets. The fate of the war may depend on how fast you can build ships. Kaiser stands. Then I'll build them faster than anyone thinks possible. March 1942. Richmond shipyard expansion. Kaiser's Richmond facility explodes in size. What started as 6 building ways becomes 12, then 16. New prefabrication shops spring up across the sprawling complex, each one dedicated to a specific ship section. But Kaiser isn't satisfied with incremental improvements. He wants revolutionary change. Gentlemen, he addresses his engineering team, we're building Liberty ships in 70 days. That's good. The best traditional yard is taking 230 days. But 70 days isn't adequate. Here's why. He writes on a chalkboard. Liberty ship construction timeline. 70 days per ship, 16 building ways at Richmond. Maximum production, 84 ships per year from Richmond. We have 18 yards building Liberty ships. If every yard matched our performance, which they're not, we'd produce 1,512 ships per year. That's good, but not good enough. U-boats are sinking ships at increasing rates. We need to build faster than they can sink. Much faster. What's the target? Calhoun asks. 30 days per ship, Kaiser states. 1 month. That would give Richmond alone 192 ships per year. Multiply across all 18 yards, and we could theoretically produce 3,456 ships per year. More than enough to overwhelm U-boat losses. Boss, Bedford objects, 30 days is impossible. We've shaved construction time from 245 days to 70 days. That's remarkable. But cutting another 40 days? The physics won't allow it. Steel takes time to cut. Welds take time to cool. Sections take time to assemble. There are hard limits. Are there? Kaiser challenges. Or are there just assumptions? Every time we've questioned an assumption, we've found a better way. Why is 70 days the minimum? What's actually limiting us? His engineers brainstorm. The analysis reveals bottlenecks. 1. Prefabrication shop capacity. Not enough sections being produced simultaneously. 2. Assembly sequencing. Sections waiting for previous sections to be installed. 3. Welding time. Thousands of welds per ship, each requiring skilled welders. 4. Material delivery. Steel and components arriving just in time, causing delays. 5. Worker training. New workers taking too long to reach proficiency. Let's solve each bottleneck, Kaiser orders. Solution 1. Expand prefabrication. Kaiser doubles, then triples prefabrication capacity. Instead of building sections as needed, Richmond begins stockpiling prefabricated sections, bow sections, stern sections, midship sections, deck houses, engine rooms, all pre-built, waiting for assembly. Build a complete ship in pieces before the keel is even laid, Kaiser explains. When we start assembling, every section is ready. No waiting, no delays. Solution 2. Parallel assembly. Traditional shipbuilding is sequential. Lay the keel, build up from the bottom, add each deck, install equipment, launch. Kaiser's method is parallel. Multiple crews work on different sections simultaneously. While one crew installs the bow, another installs engines, another installs deck machinery. Think of it like building a house, Kaiser tells workers. You don't wait for the foundation to finish before framing walls. You prepare everything in advance, then assemble rapidly. Solution 3. Welding innovation. This is the breakthrough that changes everything. Traditional shipbuilding uses riveting, individually hammering hot rivets through overlapping steel plates. It's slow, labor-intensive, requires skilled riveters. A single Liberty ship needs 2.5 million rivets installed by hand. Kaiser's ships use welding instead of riveting wherever possible. Welding is faster. Run a bead along a seam instead of hammering thousands of individual rivets. But welding creates a new problem. It requires highly skilled welders, and there aren't enough of them. How do we train welders faster? Kaiser asks his training director. Traditional welding apprenticeships take 3 to 4 years. We're training people in 6 weeks. But even 6 weeks isn't fast enough if we're hiring thousands of workers. Can we simplify welding so it requires less skill? The engineering team develops the solution. Break complex welds into simple, repetitive tasks. Instead of one master welder doing all welds on a section, 10 semi-skilled welders each do one type of weld over and over. One welder does nothing but vertical seam welds on bulkheads. Another does nothing but horizontal seam welds on deck plates. Another does nothing but fillet welds on structural supports. Through repetition, workers become extremely fast at their specific weld type, even if they couldn't do other welds competently. It's de-skilling, Calhoun explains. We're taking a skilled craft and breaking it into semi-skilled tasks. Traditional welders hate it. They say it's not proper craftsmanship. But it works, and it's fast. Solution 4. Vertical integration. Kaiser doesn't wait for suppliers to deliver steel, he builds a steel mill. He doesn't wait for engine manufacturers, He negotiates exclusive priority access. He doesn't wait for shipments. He establishes dedicated rail lines directly into Richmond Yard. Control everything we can control, Kaiser explains. Eliminate dependencies. Dependencies cause delays. Solution 5. Training innovation. Richmond establishes the most sophisticated industrial training program in America. New workers, housewives, farmers, retirees, teenagers, arrive knowing nothing about shipbuilding. Within 2 weeks, they're productive workers. How? By reducing shipbuilding to simple, teachable tasks. You don't need to understand how to build an entire ship, trainers explain. You just need to understand how to install this specific component, using these specific tools, following these specific steps. Repeat 50 times per shift. That's your job. One worker might spend entire shifts installing the same type of pipe fitting. Another installs electrical junction boxes. Another welds the same seam pattern on identical sections. It's boring. It's repetitive. It's not traditional craftsmanship. But it's fast. And it works. May 1942, the 70-day barrier breaks. Richmond completes Liberty ship SS William Clark in 62 days, then SS Charles Kendall in 54 days, then SS Francis Lewis in 48 days. The construction timeline is collapsing through continuous optimization. Every ship teaches lessons that get applied to the next ship. But Kaiser wants more. We're not trying to be the fastest traditional shipyard, he tells his team. We're trying to prove that ships can be manufactured like automobiles. Ford produces 1 car every 93 minutes. 1 ship per month is still too slow. I want 1 ship per week. Boss, Bedford protests, a Liberty ship isn't a car. It's 10,000 tons of steel, 2,000 tons of machinery, millions of individual components. 1 week is physically impossible. Is it? Kaiser challenges. Or is that just an assumption? He walks to the window overlooking Richmond Yard. 16 slipways, each with a Liberty ship in various stages of construction. Thousands of workers swarming over the ships. Cranes swinging prefabricated sections into place. Welding arcs flashing like stars. The organised chaos of mass production. What if, Kaiser muses, we built 1 ship as fast as humanly possible? Not as a production standard, but as a demonstration. Prove that it's physically possible, then figure out how to make it repeatable. A demonstration, Calhoun asks. A publicity stunt, if you're being honest, but also a proof of concept. Take our best workers, our best equipment, prepare every single section in advance, then assemble 1 ship as fast as possible. How fast could we go? Bedford calculates. If everything was pre-built, if every section was ready, if we had unlimited workers and no constraints, theoretically we could assemble a ship in maybe 10 days? 2 weeks? But that's not realistic for production. Don't care about realistic, Kaiser interrupts. I want to know what's possible. Set it up, pick a ship, prepare everything, then build it as fast as you can and show the world what American industrial capacity looks like when it's fully unleashed. His engineers exchange glances. They recognize this look. Henry Kaiser is about to do something impossible again. September 1942. The challenge. Richmond Yard issues an internal challenge. Build 1 Liberty ship in record time. Not for production efficiency, but as a demonstration of maximum possible speed. We're going to show Washington, show Britain, show Germany, and show the entire world what America can do when we stop arguing about whether something is impossible and start doing it.
Kaiser announces to assembled workers. The ship selected, SS Robert E. Peary. Keel laying scheduled for September 27, 1942. Preparation is meticulous. Every single section is pre-built and stockpiled. Bow section, complete and ready. Stern section, complete and ready. All midship sections, complete and numbered for sequence. Engine room, pre-assembled with engines installed. Deck house, complete with all fixtures. All piping, pre-cut and ready for installation. All electrical, pre-run and tested. All deck machinery, assembled and ready to bolt down. The prefabrication is so complete that the actual shipbuilding becomes pure assembly, connecting pre-built sections like Lego blocks. How fast? Kaiser asks his construction supervisor. Boss, if we go 24 hours a day, 3 shifts, no delays, maybe 7 days? But that's not including sea trials, inspections. 7 days, Kaiser repeats, from keel laying to launch. Can you do it? I think, yes, if nothing goes wrong. Then do it, and invite the press. I want newspapers, newsreels, photographers. I want the whole country watching. Show them what American workers can do. September 27th, 1942, 12:01 a.m. The clock starts. September 27th, 1942, 12:01 a.m. Richmond Shipyard No. 2. The keel of SS Robert E. Peary is laid. In traditional shipbuilding, this moment begins an 18-month process. At Richmond, using standard optimized procedures, it begins a 50-day process. Tonight, it begins something unprecedented. The yard is illuminated by thousands of floodlights, turning night into artificial day. 3 full shifts, 4,500 workers, are committed exclusively to Peary. Every other ship in the yard continues normal construction, but Peary gets priority for everything: cranes, materials, supervision, the most experienced workers.
First milestone, keel to bottom sections, announces construction supervisor Joe Stapleton over the loudspeaker system. Pre-built double bottom sections are staged and ready. Crane teams begin placement. Massive cranes swing into action, lifting 30-ton prefabricated double bottom sections from the staging area. These sections, each one representing weeks of work in the prefabrication shops, are lowered into position on the keel. In traditional construction, each plate of the double bottom would be individually cut, fitted, and riveted in place on the keel. That process takes weeks. Kaiser's prefabricated sections snap into place in hours. Workers swarm over each section as it's set, connecting sections with pre-positioned bolt holes, running tack welds to hold everything temporarily, preparing for final welding. "This is insane," mutters a visiting naval inspector, watching the organized chaos. "They're building a ship like assembling a bicycle." "That's the point," replies a Richmond foreman. "Break it into simple assembly steps. Anyone can bolt sections together if the sections are built correctly." By 6 a.m., 6 hours after keel laying, the entire double bottom is in place. What traditionally takes 2 weeks is complete in 1 night shift. September 27th, 1942, 8 a.m. Day shift takes over. The next phase, vertical construction. Pre-built bulkhead sections, the internal walls that divide the ship into compartments, are craned into position and welded to the deck. "Think of it like building a house," Stapleton explains to a newsreel crew filming the construction. "You've got your foundation. That's the double bottom we laid last night. Now we're putting up walls, these bulkheads. Then we'll add floors, the deck sections. Then the roof. That's the weather deck. And finally, all the interior systems, plumbing, electrical, machinery." "How long does each phase take?" the reporter asks. "In traditional building, each phase takes weeks, sometimes months. We're doing each phase in hours by using pre-built sections." The reporter watches a complete bulkhead section, 40 feet tall, pre-welded and tested in the fabrication shop, being lifted by 2 cranes working in tandem. The section weighs 15 tons. It's lowered into position, fitting perfectly into pre-marked locations on the deck. "How do you ensure it fits?" the reporter asks. "Aren't there tolerances, variations?" "That's the genius of Kaiser's system," the foreman explains. "All sections are built to exact specifications using jigs and templates. Every bow section is identical. Every midship section is identical. They're like parts from a factory. They fit because they're manufactured to fit, not custom built in place." By 6 p.m., 18 hours after keel laying, all major bulkheads are installed. The ship has internal structure. It's beginning to look like a ship rather than a flat platform. September 27th, 1942, 10 p.m. Night shift returns. Now comes the critical phase, hull plating. The external steel skin that makes the ship watertight. Prefabricated hull plates, each one 20 feet by 30 feet, pre-cut with all openings for portholes and hatches, are positioned against the internal structure. Welding teams attack each plate simultaneously. This is where Kaiser's de-skilled welding system shines. 20 welders work on a single hull plate. 4 welders do the top horizontal seam. 4 do the bottom horizontal seam. 4 do the vertical seams connecting to adjacent plates. 4 do the fillet welds connecting plate to internal structure. 4 do finishing passes, ensuring watertight integrity. Each welder does the same weld pattern over and over. They're not master craftsmen who can do any weld. They're specialists who do one specific weld extremely well through constant repetition. "My husband was a welder for 30 years, one female welder tells a reporter. "Worked on bridges, buildings, everything. He tried to teach me welding and said I'd never learn. Too complicated. But here, I do one type of weld. I've done it 10,000 times. I'm probably better at this specific weld than my husband ever was, because all I do is practice this one thing." By September 28th, 6 a.m., 30 hours after keel laying, the hull is 60% plated. The ship is taking shape. September 28th, 1942, Day 2. The pace accelerates. Multiple operations occur simultaneously. Hull plating teams continue working forward and aft, completing the external skin. Deck installation teams begin laying prefabricated deck sections. These aren't individual plates, they're complete deck panels, 30 feet by 40 feet, with all reinforcement structure already welded underneath. Engine installation team prepares for the most critical operation, dropping the pre-assembled engine into the engine room. "This is revolutionary," explains Chief Engineer Clay Bedford to visiting Maritime Commission officials. "Traditional construction installs the engine piece by piece. Bring in the main shaft, install it. Bring in the turbine, install it. Connect everything, test everything. Takes weeks. We pre-assemble the entire propulsion plant in a shop. The main engine, reduction gears, auxiliary systems, everything connected and tested. Then we lift the whole thing as one unit and drop it into the engine room. It's a 200-ton lift, but it saves 3 weeks of installation time." At 2 p.m., 38 hours after keel laying, 2 massive cranes position themselves over Peary. The pre-assembled engine package, a complete propulsion system weighing 200 tons, is lifted from the assembly shop. Hundreds of workers stop to watch. This is the critical moment. If the engine doesn't fit perfectly, if measurements are off by even inches, the entire timeline collapses. The engine descends slowly into the engine room. Workers guide it with ropes, making micro-adjustments. Lower, lower. The mounting points align. Perfect fit. "Bolt it down," Stapleton orders. "Connect all systems." Teams swarm over the engine, securing mounting bolts, connecting fuel lines, connecting steam lines, connecting electrical systems. What traditionally takes 3 weeks will be completed in 3 hours, because every connection is pre-planned, pre-measured, pre-tested. By 6 p.m., 42 hours after keel laying, the engine is installed and connected. A Liberty ship that couldn't move under its own power for weeks after launch in traditional construction is nearly ready to operate. September 28th, 1942, night shift. The pace becomes frantic. Workers know they're witnessing something historic. Word has spread through Richmond, through the Bay Area, through California. Newspapers are running updates every 6 hours. Radio announcers are providing progress reports. "They're building a ship in less than a week," one broadcaster announces. Richmond shipyard is demonstrating what American industrial capacity can achieve. While Germany builds 1 U-boat per month, America is proving we can build 1 cargo ship per week, maybe faster. The night shift focuses on completion. Deckhouse installation. The pre-built superstructure, containing crew quarters, bridge, radio room, galley, is craned into position as a single 40-ton unit. It's bolted and welded to the deck. Traditional construction builds the deckhouse deck by deck over weeks. Richmond installs it complete in 4 hours. Mast and rigging. Pre-assembled masts with all rigging, lights and radio antennas attached are installed. Traditional, days. Richmond, hours. Deck machinery. Winches, cargo booms, anchor windlass, all pre-assembled and tested, are bolted into pre-positioned mounting points. Traditional, weeks. Richmond, shift. Piping systems. This is where prefabrication pays massive dividends. Every pipe run was pre-cut to exact lengths, pre-threaded, pre-tested. Workers don't measure and cut pipe. They install pre-cut pipe. It's like assembling with prefab parts. Electrical systems, same story. Pre-cut cables, pre-wired panels, junction boxes that snap into pre-positioned mounts. The electrical system isn't built, it's installed. September 29, 6 a.m. 54 hours after keel laying, SS Robert E. Peary is structurally complete. The ship exists. Hull, decks, superstructure, machinery, systems, all installed. But it's not finished. It needs testing, inspection, finishing work. September 29, 1942, Day 3. The focus shifts from construction to completion. Watertight integrity testing. Compartments are pressurized to verify all welds are sound. Any leaks are identified and repaired immediately. Electrical system testing. Every circuit is tested, every motor, every light, every radio. Problems are diagnosed and fixed on the spot. Propulsion system testing. The engine is fired up, first time under power. Engineers run it through basic tests, checking for issues. Minor adjustments are made. Steering system testing. The rudder is connected and tested. All steering controls are verified. Safety equipment installation. Life rafts, fire suppression systems, emergency equipment, all installed and tested. Painting. Crews apply protective coatings to the hull. It's not beautiful. This is quick spray coating, not careful brushwork, but it protects against corrosion. The work is less dramatic than construction, but equally critical. A ship that can't pass inspection doesn't help the war effort. Maritime Commission inspectors crawl through every compartment, testing every weld, checking every system. They're looking for any excuse to delay launch. Kaiser's methods are still controversial, and many traditional naval architects believe prefabricated ships are inherently inferior. They find nothing disqualifying. The welds are adequate, one inspector admits grudgingly. Not beautiful, you can see they're done by semi-skilled workers, but they're sound. The ship is structurally solid. Systems are functional, engine runs properly, electrical works, steering responds. She meets all specifications for a Liberty ship. I don't like how she's built. This isn't proper shipbuilding, but I can't deny she's a proper ship. September 30, 6 a.m., 78 hours after keel laying, SS Robert E. Peary is declared complete and ready for launch. September 30, 1942, launch preparation. We can launch today, Stapleton reports to Kaiser. 78 hours from keel to launch. 3 days and 6 hours. Boss, that's the fastest ship ever built in history. Kaiser shakes his head. Not good enough. I told the press we'd break records. 3 days is good, but it's not record-shattering. How much more work is absolutely necessary before launch? Honestly, just final inspections and release from the blocks. Maybe 4 hours of work. Then we work through today and launch before midnight. I want this ship completed in less than 4 days. 4 days becomes the headline, not 3.5 days. Boss, why does it matter? We've already proven. Because less than 4 days is memorable, Kaiser explains. It's a number people can grasp. 3 days sounds fast. 4 days sounds impossible. I want people to remember this. I want Berlin to hear about this. I want Tokyo to hear about this. I want them to understand what they're up against. The final hours are a blur of activity. Final inspections, last-minute adjustments, documentation completion, crew briefing for sea trials, preparing the launch ceremony. September 30, 1942, 3:29 p.m. Admiral Emory Land stands at the microphone on the platform beside SS Robert E. Peary. Behind him, the completed Liberty ship sits on the building ways, ready to slide into the water. Ladies and gentlemen, Land begins. I came to Richmond shipyard skeptical of Henry Kaiser's methods. I believed shipbuilding required traditional craftsmanship, experienced workers, proper time for proper work. I was wrong. Behind me sits a 10,000-ton cargo vessel, structurally complete and seaworthy. 78 hours ago, this was an empty slipway. In less than 4 days, American workers built a ship that would take 18 months using traditional methods. This ship represents more than industrial achievement. It represents American determination. It represents what happens when we stop saying, "That's impossible," and start saying, "How do we make it possible?" Germany is building U-boats to sink our shipping. Japan is building warships to control the Pacific. But America is building cargo ships, building them so fast, in such quantities, that no enemy can sink them faster than we replace them. This ship, completed in 4 days, is one ship. But multiply this across 18 shipyards, across hundreds of building ways, and you see the future, a tide of steel, an ocean of American production capacity, an industrial might that cannot be defeated. Let's launch her and start building the next one. The crowd erupts in cheers. Restraining blocks are knocked away. SS Robert E. Peary begins sliding down the greased ways towards San Francisco Bay. 4 days, 15 hours, 29 minutes from keel laying to launch. The impossible has become reality. October 1942, Berlin, Germany. Albert Speer, Minister of Armaments and War Production, sits in his office reading translated intelligence reports from American newspapers. The reports describe Richmond Shipyard's achievement. 1 cargo ship built in 4 days. This must be propaganda, Speer mutters. American exaggeration. His assistant shakes his head. We've verified through multiple sources, Herr Minister. The ship exists. Multiple journalists witnessed the construction. Maritime Commission officials inspected and approved it. The Americans actually built a 10,000-ton cargo vessel in 4 days. Speer does the arithmetic. It's devastating. If one shipyard can build a ship in 4 days, they could theoretically produce 90 ships per year from a single building way. Multiple that by 16 ways at Richmond, that's 1,440 ships per year from one facility. And they have how many shipyards building these Liberty ships? 18 yards, Herr Minister. Varying capacities, but even at half Richmond's efficiency, the Americans could theoretically produce over 10,000 ships per year. Speer sets down the report. The mathematics are terrifying. How many merchant ships are we sinking with U-boats? Approximately 700 per year at current rates, Herr Minister. Then we're losing. Even if we doubled U-boat production, tripled the kill rate, it wouldn't matter. The Americans can build ships faster than we can sink them, much faster. Speer pulls out German shipbuilding statistics. German merchant ship production. Average construction time, 18 months per ship. Total shipyards, 12 major facilities. Annual production capacity, approximately 100 ships. Limiting factors: steel allocation, skilled labour, bombing damage to yards. American Liberty ship production. Average construction time, 42 days and dropping. Total shipyards, 18 facilities. Annual production capacity, approximately 2,500 ships and increasing. Limiting factors, none apparent. We're not competing in the same category, Speer says quietly. We're building ships with craftsmen using traditional methods. They're manufacturing ships with factory workers using industrial processes. It's like comparing a blacksmith making horseshoes to a factory producing automobiles. They're not better at shipbuilding. They've made shipbuilding irrelevant by inventing ship manufacturing. Should we attempt to copy their methods? The assistant asks. With what resources? With what workers? With what time? Even if we started today, it would take 2 years to build prefabrication facilities, train workers, develop the processes. By then, the Americans will have produced 5,000 ships. The war will already be lost. Speer writes a memo to Hitler. American industrial capacity is proving insurmountable. Their ability to mass-produce cargo vessels threatens to overwhelm our U-boat campaign, regardless of tactical success. Recommend strategic reassessment. The memo is filed and ignored. Germany continues its submarine war, sinking Allied ships at a steady rate. But the arithmetic has already turned against them. November 1942, Richmond Shipyard. SS Robert E. Peary's 4-day construction was publicity, not standard practice. But it proved what's possible. And Kaiser's engineers immediately ask, how do we make the impossible routine? We can't sustain 4-day construction, Bedford explains to Kaiser. That required every prefabricated section ready, optimal worker assignments, no delays. It's not realistic for continuous production. But what about 10 days? Kaiser asks. What about 2 weeks? We're currently averaging 42 days per ship. Can we cut that in half? Maybe, if we apply lessons from Peary. The key insight: Assembly is faster than construction. The more we pre-build, the faster the final assembly. So we expand prefabrication capacity. Kaiser approves massive expansion. New prefabrication shops. Bow section shop. Produces complete bow assemblies 2 per day. Stern section shop. Produces complete stern assemblies 2 per day. Midship section shop. Produces modular midship sections 8 per day. Deckhouse shop. Produces complete superstructures 2 per day. Engine assembly shop. Produces pre-assembled propulsion plants 1 per day. We're building a ship factory, Kaiser explains to visiting congressional delegates. Not a shipyard where craftsmen build individual ships. A factory where workers assemble pre-manufactured ship components. The difference is critical. In a shipyard, skilled workers build slowly and carefully. In a factory, semi-skilled workers assemble quickly and efficiently. We've chosen efficiency over craftsmanship because efficiency wins wars. By January 1943, Richmond's average construction time drops to 27 days per ship. By March 1943, it reaches 24 days. The yard is producing 1 Liberty ship every 24 days per building way. 16 building ways means a completed ship leaving Richmond every 1.5 days. But Kaiser still isn't satisfied. January 1943, total production scaling. The Liberty ship program expands across America. Major shipyards building Liberty ships. Bethlehem Fairfield Shipyard, Baltimore, 8 ways, 384 ships built. California Shipbuilding Corporation, Los Angeles, 8 ways, 467 ships built. Delta Shipbuilding, New Orleans, 8 ways, 188 ships built. J.A. Jones Construction, Brunswick, Georgia, 6 ways, 85 ships built. Kaiser Richmond Yards, 1, 2, 3, 31 ways total, 747 ships built. Kaiser Vancouver Yard, Portland, Oregon, 10 ways, 140 ships built. Marinship, Sausalito, 6 ways, 93 ships built. New England Shipbuilding, Portland Metals, 7 ways, 266 ships built. North Carolina Shipbuilding, Wilmington, 8 ways, 243 ships built. Oregon Shipbuilding, Portland, Oregon, 10 ways, 330 ships built. Permanente Metals, Richmond No. 4, 7 ways, 489 ships built. St. John's River Shipbuilding, Jacksonville, 8 ways, 82 ships built. Southeastern Shipbuilding, Savannah, 6 ways, 88 ships built. Todd Houston Shipbuilding, Houston, 6 ways, 208 ships built. Walsh Kaiser, Providence, 8 ways, 79 ships built. Total, 18 major shipyards, 150 plus building ways, producing Liberty ships continuously. Not all yards adopt Kaiser's methods. Traditional shipbuilders like Bethlehem Steel resist prefabrication, insisting on conventional construction. Their production times remain slow, 60 to 90 days per ship. But enough yards adopt Kaiser's innovations that average production times across all facilities drop from 105 days, January 1942, to 42 days, December 1942, to 39 days, June 1943. The arithmetic becomes overwhelming. 1942. Production, 597 Liberty ships completed. 1943. Production, 1,949 Liberty ships completed. 1944. Production, 1,490 Liberty ships completed. By mid-1943, Liberty ships are being completed faster than crews can be trained to sail them. Ships sit at docks waiting for sailors. We're building ships faster than we can use them, Admiral Land reports to President Roosevelt. Kaiser's methods have solved the production problem so completely that we now have a different problem. What do we do with all these ships? Roosevelt smiles. That's the best kind of problem to have in a war. March 1943. The human cost. Not everything about Liberty ship production is triumphant. The speed comes with consequences. Labour conditions. Richmond employs 90,000 workers at peak production, working 3 shifts, 24 hours a day, 7 days a week. The pace is brutal. 10-hour shifts, despite 8-hour contracts. Mandatory overtime. 6-day weeks standard, 7-day weeks common. Dangerous conditions, falls, crushing injuries, burns from welding. I've worked construction my whole life, one middle-aged welder tells a reporter. Bridges, dams, buildings. Nothing was as hard as Richmond. The pace never stops. There's always another ship starting, another ship launching, always pressure to go faster, weld more, produce more. It breaks people. Injury rates are high. Safety standards, while better than 1940s norms, are compromised by production pressure. Workers fall from staging. Cranes drop loads. Welding accidents cause burns. The shipyards are dangerous places. But workers keep coming because the pay is good and the work matters. They know each ship carries supplies to Allied forces, brings soldiers home, supports the war effort. That knowledge sustains them through brutal conditions. Quality concerns. The rapid construction raises persistent questions about ship quality. Traditional shipbuilders insist that prefabricated ships welded by semi-skilled workers cannot match the structural integrity of riveted ships built by craftsmen. They're partially right. Liberty ships have problems. Structural failures. Some Liberty ships develop cracks in welded seams, particularly in cold water. The cracks propagate through continuous welded seams, something that can't happen with riveted construction where each rivet is independent. SS Schenectady, January 1943. Breaks completely in half while docked in calm water in Portland. The ship literally splits into two pieces at a welded seam. Investigation reveals brittle fracture caused by poor steel quality and welding technique. SS John P. Gaines, November 1943. Breaks in half during a storm in the North Pacific. The ship's back breaks at a welded deck seam. Between 1943 to 1945, approximately 1,500 Liberty ships experienced serious structural cracks. 3 break completely in half. 19 sink due to structural failure. This proves Kaiser's methods are unsafe, traditional shipbuilders argue. You cannot mass-produce ships with semi-skilled labour and expect them to be seaworthy. Kaiser's response: 19 ships lost to structural failure out of 2,710 ships built is a 0.7% failure rate. That's statistically better than many traditionally built ship classes. Yes, we've had failures. We've learned from them, improved our steel specifications, improved our welding techniques. The solution isn't to go back to slow traditional construction. The solution is to fix the problems and keep producing. By late 1943, modifications are implemented. Steel specifications improved to prevent brittle fracture. Welding procedures updated based on failure analysis. Riveted crack arrestor straps added at high stress points. Quality control inspections. The structural failure rate drops to nearly zero by 1944. June 1943. Statistical superiority. The US Maritime Commission publishes comprehensive Liberty ship statistics. Liberty ship production, January 1942 to June 1943. Ships completed, 1,022. Average construction time, 42 days. Fastest construction, 4 days, 15.5 hours, SS Robert E. Peary. Total deadweight capacity, 10.2 million tons. For comparison, German U-boat sinkings, January 1942 to June 1943. Allied ships sunk, 1,234. Total tonnage sunk, 6.9 million tons. Critical statistic: America is building cargo capacity faster than Germany can sink it. For every 3 ships sunk, America builds 5 new ones. The deficit is being reversed. By September 1943, the statistics become even more favourable. Liberty ships completed, 1,546, cumulative. Allied ships sunk, 1,678, cumulative. But the deadweight capacity tells a different story. Liberty capacity built, 15.4 million tons. Allied capacity sunk, 9.3 million tons. America has added 6.1 million tons of net shipping capacity. Despite U-boat successes, the Allied merchant fleet is growing, not shrinking. By December 1943, the U-boat threat is effectively neutralized. Not because U-boats are defeated tactically, but because their strategic impact is overwhelmed by American production. Admiral Karl Dönitz, commander of Germany's U-boat fleet, writes in his diary, "We are sinking ships at a rate that should devastate Allied logistics, but they are building ships faster than we can sink them. The mathematics of this war have turned against us." September 1943, Kaiser's reflection. Henry Kaiser stands in Richmond shipyard, watching SS George Washington Carver slide down the ways, the 500th Liberty ship built at Richmond facilities. A reporter asks, "Mr. Kaiser, they're calling you the man who won the war with shipbuilding. How does that feel?" Kaiser shakes his head. "I didn't win anything. 90,000 workers at Richmond won something. The welders who do the same seam 10,000 times. The crane operators who position 30-ton sections with inch-perfect accuracy. The supervisors who coordinate thousands of people in organized chaos. They're the heroes, not me." "But you created the system. You proved ships could be mass-produced." "I proved something simpler," Kaiser replies. "I proved that impossible is usually just never been tried. Traditional shipbuilders said, you can't build ships in less than 18 months. Why? Because that's how long it always took. But nobody had seriously tried to build them faster using modern manufacturing methods. The real innovation wasn't shipbuilding technique. It was asking, why not? Why can't ships be prefabricated? Why can't semi-skilled workers do specialized tasks? Why can't we organize shipbuilding like automobile production?" Every time someone said, "That's impossible," we asked, why? And usually the answer was, because we've never done it that way. That's not a reason, that's just tradition. So you ignored tradition? No, Kaiser corrects. We learned from tradition, then improved on it. Traditional shipbuilders know things we don't, about ship design, hydrodynamics, structural engineering. We didn't reject that knowledge, we applied it differently. We took the knowledge of what makes a good ship and combined it with knowledge of what makes efficient manufacturing. The result is Liberty ships. Not the most beautiful ships, not the fastest ships, not the most sophisticated ships, but adequate ships, produced in quantities that win wars. The reporter scribbles notes. "One more question. What's next? You've revolutionized cargo ship production. What's the next impossible thing?" Kaiser smiles. "Aircraft carriers. We're going to build aircraft carriers using the same prefabrication methods. Traditional construction, 3 years per carrier. We think we can do it in 18 months. The Navy says it's impossible. And you'll prove them wrong?" "Of course, that's what we do." April 1944, Atlantic Ocean. Liberty ship SS Jeremiah O'Brien plows through heavy North Atlantic seas, part of a convoy heading to England. Her holds are packed with supplies, trucks, ammunition, food, medical supplies, fuel, everything the Allied forces in Britain need to prepare for the invasion of Europe. Captain Hugo V. Neubert stands on the bridge, watching grey waves break over the bow. Jeremiah O'Brien is 18 months old, built at New England Shipbuilding in Portland, Maine, in 56 days. She's not beautiful, her welds are visible, her finish is utilitarian, but she's seaworthy, and that's all that matters. "Captain," the radio operator calls. "Convoy Commodore reports U-boat Wolfpack detected ahead. Evasive course change ordered." Neubert acknowledges. This is the third U-boat alert in 2 days. German submarines are still hunting Atlantic convoys, still sinking Allied ships. But the calculus has changed fundamentally. In 1942, U-boats were winning the Battle of the Atlantic. They sank ships faster than the Allies could replace them. Every merchant ship lost was a strategic victory for Germany. In 1944, U-boats are losing. They still sink ships, but for every ship they sink, America launches 3 more. The deficit is reversed. The mathematics favour the Allies. "Sir," the executive officer observes, "I've been thinking about this ship. She was built in less than 2 months by workers who'd never built a ship before. Traditional naval architects said it was impossible, said ships built that fast would be unsafe, structurally unsound. Yet here we are," Neubert replies. 18 months of hard service, Atlantic storms, heavy cargo, constant operation. She's held together perfectly. Whatever those workers did in Portland, they did it right. It's because they didn't know shipbuilding was supposed to be complicated, the XO suggests. They just followed instructions, welded what needed welding, bolted what needed bolting. No preconceptions about how ships should be built. They built her the way the plans specified, and the plans were designed for exactly that kind of construction. 2 days later, Jeremiah O'Brien arrives safely in Liverpool. Her cargo is unloaded, supplies that will support Allied forces in the upcoming invasion. She refuels, takes on ballast, and departs for America to collect another load. Over the next year, Jeremiah O'Brien will make 11 round trips across the Atlantic. She'll carry 29,000 tons of cargo. She'll survive 2 U-boat attacks, multiple storms, and constant hard use. She's one ship, but she's representative of 2,710 Liberty ships doing the same work, a steel conveyor belt carrying the materials of war across oceans. June 6, 1944, D-Day, Normandy, France. The invasion of Europe begins. 156,000 Allied soldiers land on French beaches, supported by the largest amphibious fleet ever assembled. 6,939 vessels, including battleships, cruisers, destroyers, landing craft, and cargo ships. Among them, 126 Liberty ships, positioned off the beaches, serving as floating supply depots. Liberty ship SS Charles Morgan sits 3 miles offshore, her 5 cargo holds packed with ammunition, fuel, rations, medical supplies, vehicles. As fast as landing craft can shuttle to the beach, Morgan's crew offloads cargo. Stevedores work around the clock. Winches swing cargo nets full of supplies over the side. Landing craft pull alongside, fill their holds, then race to the beaches. Return empty. Repeat. The cycle continues for days. "This is what we were built for," Morgan's captain tells his crew. "Not glamorous, not heroic, just moving cargo from ship to shore as fast as possible. But this cargo keeps those boys on the beach fed, armed, and advancing. Every crate of ammunition is another 100 yards gained. Every fuel drum is another mile the tanks can push forward." Over the next 6 weeks, Liberty ships deliver 2.5 million tons of supplies to Normandy beaches: ammunition, fuel, food, vehicles, replacement equipment. The logistics of the invasion depend entirely on these unglamorous cargo vessels, and they're available in such quantities that losses don't matter. When Liberty ship SS Charles H. Kugel is sunk by a mine off Omaha Beach, 3 more Liberty ships arrive the next day to replace her. When SS Edward M. House is bombed by Luftwaffe aircraft, 2 more ships move into her position. The Allies can afford losses because Kaiser's shipyards are still producing. Even in mid-1944, with the U-boat threat largely defeated and cargo capacity exceeding requirements, the yards keep building, because wars are won by surplus, not by adequacy. August 1944, Pacific Theatre. Liberty ships face different challenges in the Pacific. Distances are vast, 7,000 miles from San Francisco to the Philippines, 5,000 miles to Australia. Ships must cross open ocean for weeks, often without escort, carrying supplies to island bases scattered across millions of square miles. Liberty ship SS Jean Nicolet departs San Francisco loaded with construction equipment, cement, lumber, and water purification systems, everything needed to build an advanced base on a newly captured Pacific island. The voyage to Tarawa Atoll takes 23 days. The ship plows through empty ocean, her crew of 44 merchant sailors and 21 Navy armed guard maintaining constant vigilance for Japanese submarines and aircraft. "We're basically a floating warehouse," explains Chief Engineer Walter Hayes. "The cargo we're carrying will build water systems, repair facilities, fuel depots on Tarawa. When the Marines captured that island, it was coral sand and destroyed Japanese fortifications. We're bringing everything needed to turn it into an American base." Nicolet arrives at Tarawa and anchors in the lagoon. Over the next 4 days, Navy construction battalions, Seabees, offload her entire cargo: bulldozers, cement mixers, lumber, pipe, wire, tools, tents, food, fuel. Within weeks, Tarawa transforms from battlefield to functioning base, capable of supporting the next offensive operation. And that base exists because Liberty ships carried the materials to build it. This pattern repeats across the Pacific. Marines capture an island, Liberty ships deliver supplies, Seabees build infrastructure, the island becomes a base for the next operation. The advance across the Pacific depends on logistics, and Liberty ships are the logistics. People think wars are won by Marines storming beaches or pilots shooting down enemy planes, Hayes reflects. But wars are really won by cargo capacity. Can you move more supplies to the battlefield than the enemy can? Can you sustain operations longer? Can you replace losses faster? That's what determines victory. And Liberty ships, these ugly, unglamorous cargo vessels built in a few weeks by housewives and farmers, are what give America that logistical superiority. Not because each ship is special, but because there are so many of them. December 1944. Total War Logistics. The US Maritime Commission publishes comprehensive statistics showing Liberty ships' contribution to Allied victory. Liberty ship production, 1941 to 1944. Total ships completed, 2,580. Total deadweight capacity, 25.8 million tons. Average construction time, 42 days. Total cost, $2 billion, $14 million per ship. Cargo carried, 1942 to 1944. Total cargo volume, 75 million tons. Ammunition, 8 million tons. Fuel, 18 million tons. Vehicles, 12 million tons. Food, 15 million tons. Equipment supplies, 22 million tons. Troop transport, soldiers carried, 450,000. Medical evacuations, 89,000. Operational statistics. Ships lost to enemy action, 200, 7.7% of total. Ships lost to marine casualties, 31, 1.2% of total. Ships surviving war, 2,349, 91.1% of total. The survival rate is remarkable, Admiral Land notes in his report to Congress. We expected 15 to 20% losses based on U-boat activity. Instead, we lost less than 8% to enemy action. Why? Because we built so many ships that we overwhelmed German targeting capacity. There were simply too many targets for U-boats to sink. More importantly, the 200 ships we lost were replaceable. When SS Stephen Hopkins was sunk in September 1942, 3 more Liberty ships were completed that same week. When SS Paul Hamilton was torpedoed in April 1944, 5 more launched within days. Germany could sink our ships faster than they could be replaced in 1941, 1942. By 1943, 1944, we were building ships 10 times faster than they could sink them. That's not tactical victory, that's mathematical inevitability. February 1945, the final statistics. The last Liberty ship, SS Albert M. Bow, is completed at California Shipbuilding Corporation in Los Angeles. Construction time, 31 days. Final Liberty ship production totals. Total Liberty ships, 2,710, built by 18 shipyards. Kaiser Richmond, 4 yards, 747 ships. California Shipbuilding, 467 ships. Permanente Metals, 489 ships. Bethlehem Fairfield, 384 ships. Oregon Shipbuilding, 330 ships. New England Shipbuilding, 266 ships. North Carolina Shipbuilding, 243 ships. Todd Houston, 208 ships. Delta Shipbuilding, 188 ships. Kaiser Vancouver, 140 ships. Marin Ship, 93 ships. Southeastern Shipbuilding, 88 ships. J.A. Jones Construction, 85 ships. St. John's River, 82 ships. Walsh Kaiser, 79 ships. Construction timeline. Fastest ship, 4 days, 15.5 hours. SS Robert E. Peary, November 1942. Average construction time, 42 days. Total construction, 39 months. December 1941, February 1945. Average ships per month, 69.5 ships. Cost analysis. Total program cost, $2.6 billion. Cost per ship, $14.5 million, including tooling, facilities, training. Cost per ton of capacity, $2,058. For comparison, traditional construction. Traditional construction time, 18 months. Traditional cost per ship, $22 million. If built traditionally, 2,710 ships would have required. 4,095 months of construction, 341 years. $59.6 billion total cost. Would not have been completed until 2283, if starting 1942. The Liberty ship program represents the most significant industrial achievement in history, Kaiser declares at the final ship launch ceremony. Not because of individual ship quality, traditional ships are better built. Not because of speed, though 4-day construction is impressive, but because of scale and impact. We built 2,710 cargo ships in 39 months. That's impossible by traditional standards. It's only possible by abandoning traditional standards and embracing industrial manufacturing principles. These ships carried the materials that won the war, the ammunition that defeated Germany, the fuel that powered Allied vehicles, the food that sustained Allied armies, the equipment that built advanced bases across the Pacific. When historians ask, how did America win World War II? One answer is, Liberty ships. The unglamorous, utilitarian, mass-produced cargo vessels that proved logistics defeats tactics, quantity defeats quality, and industrial capacity determines strategic outcomes. May 8, 1945. VE Day. Germany surrenders. In harbours across the world, Liberty ships sit at anchor or dock, their holds full of supplies. They've carried 75% of all cargo shipped to European and Pacific theatres. They've sustained Allied armies across 2 continents and 2 oceans. Admiral Land calculates the contribution. Liberty ships' strategic impact. Without Liberty ships, hypothetical. Allied cargo capacity, 8 million tons. Existing merchant fleet, insufficient capacity 4. North Africa campaign, required 2 million tons capacity. Sicily-Italy campaigns, required 3 million tons capacity. D-Day and European campaign, required 12 million tons capacity. Pacific Island campaigns, required 8 million tons capacity. Result: strategic operations impossible or severely delayed. With Liberty ships, reality. Allied cargo capacity, 33.8 million tons, existing fleet plus Liberty ships. Sufficient capacity 4, simultaneous operations in Europe and Pacific, sustained logistics for armies in multiple theatres, rapid build-up of supplies for major offensives, replacement of losses without reducing operational capacity. Result: Allied forces never logistics constrained. Liberty ships didn't win battles, Land writes in his final report, but they made winning battles possible. You can't invade Normandy without cargo capacity to deliver 12,000 tons of supplies per day. You can't sustain armies in Germany without fuel, ammunition, and food. You can't capture Pacific Islands without construction materials to build bases. Liberty ships provided that capacity. Not through excellence, through abundance. We had so many cargo ships that logistics never constrained operations. That's how industrial wars are won, not by having the best weapons, but by having unlimited capacity to sustain operations. August 1945, VJ Day, Japan surrenders. Henry Kaiser stands in Richmond shipyard watching the celebration. Workers pour into the streets, embracing, crying, celebrating the end of the war. The shipyard, which at peak production employed 90,000 people and operated 24 hours a day, is eerily quiet. The last Liberty ship departed 3 months ago. New orders have stopped. The emergency that demanded impossible production no longer exists. What happens now? Asks Clay Bedford, Kaiser's chief engineer. We've built 747 ships in less than 4 years. We've proven that mass production shipbuilding works. But there's no more war to fight. What do we do with all this infrastructure? Kaiser looks across the vast facility. 16 slipways, dozens of prefabrication shops, Warehouses full of equipment, rail lines, cranes, the entire industrial apparatus of the most productive shipyard in history. We adapt, Kaiser says simply. We built this to win a war. Now we use it to win the peace. Over the next months, Kaiser converts wartime shipbuilding capacity to peacetime production. Richmond shipyard conversion. Cargo ship construction continues, civilian contracts. Tanker production begins. Conversion of military vessels to civilian use. Ship repair and maintenance services. Eventually, steel fabrication, general manufacturing. But the larger question looms. What happens to 2,710 Liberty ships now that the war is over? September 1945. The Liberty ship surplus. The US Maritime Commission faces an unprecedented problem. Too many ships. At war's end, America possesses US Merchant Fleet, September 1945. Liberty ships, 2,710 vessels, 27.1 million tons capacity. Victory ships, 531 vessels, 5.8 million tons capacity. T2 tankers, 481 vessels, 4.8 million tons capacity. Other cargo vessels, 808 ships, 8.3 million tons capacity. Total, 4,500 cargo ships, 46 million tons capacity. For comparison, the entire world merchant fleet in 1939 was 68 million tons. America alone now controls 2/3 of global cargo capacity. We have 5 times more cargo ships than we need for peacetime commerce, Admiral Land reports to Congress. Even accounting for international trade reconstruction, even assuming robust economic growth, we simply don't need 4,500 cargo vessels. The options. Option 1. Scrap them. Immediate steel recovery. 27 million tons from Liberty ships alone. Eliminates maintenance costs. Provides raw material for reconstruction. But destroys assets that cost $2.6 billion to build. Option 2. Mothball them. Preserve ships for future emergency. Maintain strategic reserve capacity. Minimal ongoing costs if properly stored. But ships deteriorate in storage, may not be usable after years of idleness. Option 3. Sell them. Recover some construction costs. Support reconstruction of Allied merchant fleets. Boost international trade capacity. But flood market with cheap ships. Devastate American shipbuilding industry. Option 4. Convert them. Modify for specialized uses. Extend service life through upgrades. Maintain employment in shipyards. But expensive conversions for ships never designed for long-term service. Congress chooses a combination approach. Liberty ship disposition, 1945 to 1970. Sold to foreign nations, 835 ships. Britain, 200 ships, reconstruction of merchant fleet. Greece, 98 ships, rebuilding war-damaged fleet. France, 65 ships. Italy, 46 ships. Netherlands, 33 ships. Norway, 27 ships. Various others, 366 ships. Sold to US commercial operators, 531 ships. Purchased by shipping companies for commercial service. Most operate 10 to 15 years before replacement. Mothballed in reserve fleet, 1,113 ships. Stored in 8 ghost fleets in bays and rivers. Preserved for emergency reactivation. Locations: James River, VA, Suisun Bay, Pennsylvania, Beaumont, Texas, Mobile, Alabama, others. Scrapped immediately, 196 ships. War-damaged vessels beyond economic repair. Ships with structural defects, excess capacity not needed for any purpose. Lost in service, 35 ships. Marine casualties, storms, groundings during peacetime operations. The Liberty ships are being dispersed across the world, Land observes. Ships built in weeks by American workers are now carrying cargo for Greek merchants, Norwegian operators, Italian companies. The ships that won the war for America are now rebuilding the world economy. 1950 to 1953. Korean War. 5 years after World War II ends, America is at war again, this time in Korea. Once more, military operations require massive logistics: troops to transport, supplies to deliver, bases to support. The US Maritime Commission reactivates 540 Liberty ships from the mothball fleet. Ships that have sat idle for 5 years are brought back to service, refitted, crewed, and sent to sea. SS Longview Victory, a Victory-class ship, Liberty's successor, returns to service after 5 years in mothball. Her captain reflects, "This ship was built in 1944, served in the Pacific, then mothballed in 1946. Now she's back at war, carrying supplies to Korea. The ship that was supposed to be a temporary emergency measure has proven more durable than anyone expected. She wasn't built to last, but here she is, still floating, still working, still moving cargo." The Korean War validates the mothball fleet strategy. The 540 reactivated ships provide immediate cargo capacity without requiring new construction. They're old, they're worn, but they work, exactly what Kaiser intended. After Korea, most Liberty ships return to mothball storage, but their utility has been proven. Emergency cargo capacity remains available for the next crisis. 1960s, 1970s, the final years. By the 1960s, Liberty ships are obsolete. They're slow, 11 knots versus 20+ knots for modern cargo ships, inefficient, reciprocating steam engines versus diesel, and small by modern standards, 10,000 tons versus 25,000+ tons for new vessels. Commercial operators sell or scrap their Liberty ships, replacing them with modern vessels. The mothball fleet shrinks as ships are scrapped. 1960, 900 Liberty ships in reserve. 1965, 450 Liberty ships in reserve. 1970, 200 Liberty ships in reserve. 1975, 75 Liberty ships in reserve. 1980, 30 Liberty ships in reserve. 1990, 5 Liberty ships in reserve. By 2000, only 2 Liberty ships remain operational. SS Jeremiah O'Brien, San Francisco Maritime National Historical Park, built, New England Shipbuilding, Portland, Maine, 1943. Construction time, 56 days. Service, Atlantic Convoy Duty, D-Day participant, Pacific Service. Status, fully operational museum ship, last operational unmodified Liberty ship, still capable of steaming under own power. SS John W. Brown, Baltimore, Maryland. Built, Bethlehem Fairfield Shipyard, Baltimore, 1942. Construction time, 63 days. Service, Atlantic Mediterranean Convoy Duty. Status, operational museum ship, conducts living history cruises, maintained in operational condition by volunteers. Both ships serve as museums, offering the public a chance to board and explore the vessels that carried victory. Volunteer crews, many of them former merchant mariners, maintain the ships in operational condition, conducting periodic sea trials to keep systems functional. These ships were built to last maybe 5 years, explains a volunteer engineer on O'Brien. Emergency construction, minimum specifications, expected to be sunk, scrapped, or worn out by 1948. Instead, here we are in the 21st century, and these ships still steam. That tells you something about the quality of adequate when adequate is built right. The legacy. 80 years after the first Liberty ships launched, their impact on warfare, industry, and history remains profound. Military legacy. The Liberty ship program established principles that define modern military logistics. 1. Mass production over craftsmanship. Modern military equipment emphasizes producibility over perfection. The M4 Sherman tank, the Jeep, the C-47 transport aircraft, all follow the Liberty ship model. Adequate design, mass production, overwhelming quantity. 2. Modular construction. Modern military ships, aircraft, and vehicles use modular construction derived from Liberty ship prefabrication. Components are built separately, tested independently, then assembled rapidly. 3. Rapid training. Modern militaries train personnel quickly for specialized tasks, rather than developing broad expertise slowly. Liberty ship welders who learned one specific weld type in days proved that specialization enables rapid capability development. 4. Industrial warfare doctrine. Wars are won by industrial capacity, not just tactical superiority. The side that can produce more equipment, faster, with adequate quality, wins through material superiority. Liberty ships proved this principle definitively. Industrial legacy. Henry Kaiser's methods revolutionized manufacturing beyond shipbuilding. Automotive industry. Kaiser applied shipbuilding lessons to automobile production, founding Kaiser Motors, later Kaiser Jeep, using prefabrication and assembly line methods. Construction industry. Prefabrication became standard in construction, buildings assembled from factory-built components rather than constructed entirely on site. Aerospace industry. Modern aircraft production uses Liberty ship principles, major sections built separately, then assembled. Boeing's 787 Dreamliner is built by suppliers worldwide, then assembled in days, exactly Kaiser's model. Manufacturing philosophy. Kaiser's question, "Why not?" became foundational to American manufacturing. Challenge assumptions, optimize processes, prioritize results over tradition. These principles drive modern industrial innovation. August 2024, Jeremiah O'Brien, San Francisco. A group of high school students tours SS Jeremiah O'Brien, the last operational Liberty ship. Their teacher, a history instructor focusing on World War II, leads them through the vessel. This ship was built in 56 days, the teacher explains. Laid down March 6, 1943, launched June 19, 1943. Less than 2 months from start to finish. Built by workers who'd never seen a ship before, housewives, farmers, shop clerks. They learned shipbuilding in weeks and produced this. The students touch the rough welds, the utilitarian fittings, the simple but functional design. Why is it so basic? One student asks. It doesn't look like a modern ship. Because it wasn't designed to be a modern ship, the teacher responds. It was designed to be an adequate ship, built impossibly fast. Look at these welds. You can see they're done by semi-skilled workers. Not beautiful, but they've held for 81 years. This ship participated in D-Day. She carried cargo to Normandy beaches. She survived the war, served in Korea, sat in mothballs for decades, and now she's a museum. A ship built to last 5 years has lasted 80 years, because adequate turned out to be more than adequate. It was excellent in disguise. A student reads from an information placard. 2,710 Liberty ships built. Average construction time, 42 days. Fastest, 4 days, 15 hours. Total cost, $2.6 billion. If built traditionally, would have taken 341 years and cost $60 billion. That's impossible, the student says. That's exactly what everyone said in 1941, the teacher replies. Impossible. Can't be done. Ships require skilled craftsmen and proper time. Then Henry Kaiser asked, why? And proved that impossible was just never tried with modern methods. The students descend into the engine room, where the original reciprocating steam engine, built in 1943, still functions. A volunteer engineer explains, this engine is 81 years old. It's been disassembled, cleaned, and reassembled many times. But the core components, the ones built in 1943 by workers who learned engine assembly in weeks, are still here, still working. That's the secret. Adequate doesn't mean inferior. It means optimized for purpose. This engine was designed to be simple, repairable, reliable. It succeeded. On the bridge, students examine navigation equipment, communication systems, the ship's wheel. Everything is functional, maintained by volunteers who ensure the ship remains operational. Why keep it operational? A student asks. Why not just make it a static museum? Because this ship represents something important, explains the captain, a retired merchant mariner who volunteers his time. It represents what America can do when challenged. When everyone says something's impossible, we figure out how to make it possible. This ship was built in 56 days by people who didn't know shipbuilding was supposed to be hard. They just built it. And it worked. It carried cargo across oceans, survived storms and combat, and it's still here. That's worth preserving. Not because this ship is special, 2,710 of them were built, but because it represents a moment when America proved that industrial will can overcome any obstacle. The students file off the ship as the sun sets over San Francisco Bay. Behind them, SS Jeremiah O'Brien sits at dock, scarred, functional, proudly utilitarian, a monument to the moment when impossible became routine. Section 7. The Impossible Made Routine. November 2024. MIT Sloan School of Management. Professor Sarah Chen teaches a graduate course on supply chain management and industrial innovation. Today's case study: Liberty Ship Production and Henry Kaiser's Manufacturing Revolution. Let's examine the numbers, Professor Chen begins, displaying a slide. Traditional shipbuilding, 1939. Construction time, 355 days average. Labour, skilled craftsmen, 5+ years training. Method, custom construction, each ship individually built. Production philosophy, quality through craftsmanship. Annual US capacity, around 100 ships across all yards. Kaiser method, 1943. Construction time, 42 days average, 27 days at Richmond Peak. Labour, semi-skilled workers, 2 to 6 weeks training. Method, prefabrication and assembly. Production philosophy, adequacy through mass production. Annual capacity, 2,000+ ships. That's an 8-to-1 improvement in construction time, Chen explains. But here's the critical question. How? What specific innovations created this improvement? A student raises his hand. Prefabrication, obviously. Building sections separately, then assembling them. Correct, but that's only part of it, Chen replies. Prefabrication existed before Kaiser. What made his prefabrication different was the scale and system design. Let me show you. She displays a diagram of Richmond Shipyard's workflow. Kaiser's prefabrication system. Stage 1, section manufacturing, days 1 to 20. Bow shop, produces complete bow assembly, 150 tons. Stern shop, produces complete stern assembly, 180 tons. Midship shop, produces 6 modular midship sections, 50 tons each. Deckhouse shop, produces complete superstructure, 80 tons. Engine shop, pre-assembles entire propulsion plant, 200 tons. Total, 7 major sections, all built simultaneously in parallel. Stage 2, staging and preparation, days 18 to 22. Completed sections moved to staging area adjacent to slipway. All sections inspected, tested, prepared for assembly. Sections numbered for assembly sequence. All connection points pre-aligned and verified. Stage 3, rapid assembly, days 21 to 35. Keel laid, day 21. Double bottom sections installed, days 21 to 23. Midship sections erected, days 24 to 28. Bow and stern sections installed, days 28 to 30. Engine dropped in, day 30. Deckhouse installed, day 31. Systems connected, days 32 to 35. Stage 4, testing and launch, days 36 to 42. Watertight integrity testing, days 36 to 38. Systems testing, days 38 to 40. Final inspection, day 41. Launch, day 42. Notice, Chen emphasizes, that actual ship assembly takes only 15 days. The other 27 days are prefabrication, testing, and inspection. Traditional construction spent all 355 days building the ship sequentially on the slipway. Kaiser spent 85% of the time preparing components, then assembled them rapidly. This is modern supply chain management before the term existed. Optimize the entire system, not just the final assembly. Build a manufacturing pipeline where components flow continuously, and final assembly is just the last step. A student asks, but didn't this compromise quality? Weren't Liberty ships inferior to traditionally built ships? Excellent question, Chen responds. Let's look at the data. She displays comparative statistics. Liberty ship quality metrics. Structural failure rate, 0.7%, 19 of 2,710 ships. War loss rate, 7.4%, 200 of 2,710 ships. Survival rate, 91.9%, 2,491 of 2,710 ships. Average service life, 17 years, designed for 5 years. Post-war service, 2,200 plus ships continued commercial operation. Ships still operational, 2024. 2 ships fully functional after 81 years. Traditionally built cargo ships, 1939 to 1941. Structural failure rate, 0.4%, slightly better. War loss rate, 22%, much worse. U-boats targeted fewer, higher value ships. Survival rate, 78%. Average service life, 15 years. Post-war service, most scrapped or rebuilt. Ships still operational, 2024, 0. So Liberty ships had slightly higher structural failure rates, 0.7% versus 0.4%, but they survived the war at higher rates because there were so many targets that U-boats couldn't concentrate on them. And they lasted longer than expected because adequate construction turned out to be surprisingly durable. The real quality metric isn't structural perfection, it's fitness for purpose. Liberty ships were designed to carry cargo for 5 years during a war. They successfully carried 75% of all Allied cargo, survived at 92% rates, and many continued service for 15-20 years post-war. By any reasonable measure, that's high quality, just not traditional quality. November 2024, Harvard Business School. Professor Michael Torres teaches a case study on organizational innovation. Kaiser Industries and the democratization of expertise. Henry Kaiser faced a problem, Torres begins. He needed to build ships but lacked skilled shipbuilders. Traditional solution: spend years training workers in comprehensive shipbuilding skills. Kaiser's solution: break shipbuilding into specialized tasks that could be learned quickly. He displays a training curriculum. Traditional shipbuilding apprenticeship. Duration: 4 to 5 years. Skills learned: complete shipbuilding knowledge, blueprint reading, multiple welding techniques, riveting, plate fitting, structural design, quality inspection, problem solving. Result: versatile craftsmen who can build any part of a ship. Kaiser Rapid Training Program. Duration: 2 to 6 weeks. Skills learned: one specific task. Example: vertical seam welding on bulkheads. Practice this one weld type repeatedly. Learn quality standards for this specific weld. Learn safety procedures for this task. Result: specialist who can perform one task excellently through repetition. This is task specialization taken to the extreme, Torres explains. Adam Smith described this in The Wealth of Nations, a pin factory where each worker does one step, producing vastly more pins than generalist craftsmen. Kaiser applied this to shipbuilding. The traditional objection is, specialized workers lack understanding. A welder who only knows one weld type can't adapt, can't problem solve, can't produce quality work. But Kaiser proved this wrong. His specialized welders produced excellent welds for their specific task, often better than generalists, because they did that weld thousands of times. They couldn't do other welds, but they didn't need to. The system was designed so that specialization was sufficient. A student objects, but what happens when something goes wrong? If a specialized worker encounters a problem outside their expertise, doesn't the system break down? Great question, Torres responds. Kaiser solved this with hierarchical expertise. Specialized workers handled routine tasks. Supervisors with broader knowledge handled exceptions. Engineers handled complex problems. Each level had appropriate expertise for their level of decision-making. Most work, 90% plus of shipbuilding tasks, was routine and repeatable. Specialized workers handled this efficiently. The remaining 10% required expertise, which supervisors and engineers provided. This is modern organizational design. Push routine decisions to the lowest level, escalate exceptions to higher expertise. The result? 90,000 workers at Richmond, most with minimal training, producing ships faster than experienced shipyards with master craftsmen. Not because individual workers were better, but because the system was better. November 2024. Oral history interview. Margaret Romano, age 101, sits in her San Francisco home, surrounded by photographs from her years as a welder at Richmond Shipyard. An oral historian records her memories. Interviewer: Mrs. Romano, you were a welder at Kaiser Richmond during the war. Romano: That's right. Started in February 1943, worked until the war ended. I was a housewife before that, never worked outside the home, never imagined I'd be building ships. Interviewer: What made you decide to work at the shipyard? Romano: My husband was in the army, fighting in Europe. I had 2 kids and not much money. The shipyard paid $1.20 per hour. That was good money in 1943. Plus, I felt like I was contributing to the war effort. Every ship we built carried supplies to support the troops, maybe even my husband. Interviewer: How did you learn welding? Romano: 2-week training course. They taught us one type of weld, vertical seam welding on bulkhead sections. That's all I ever did. I'd weld the same seam on bulkhead after bulkhead, 8 hours a day, 6 days a week. Same weld, over and over. Interviewer: Wasn't that boring? Romano: Boring? Sure, but also satisfying. I got good at it, really good. After a few months, I could lay a perfect vertical seam faster than anyone. The supervisors would bring visitors to watch me work, show them how fast a weld could be done. I took pride in that. Did you feel like you were building ships or just welding seams? Both. I knew my specific job was just one weld on one section, but I also knew that section would become part of a ship, and that ship would carry cargo across the ocean. Every weld I made was helping win the war. That kept me going even when I was exhausted. What was the pace like? Brutal. Continuous pressure to go faster. Supervisors timing us, tracking how many welds per hour. Competitions between shifts. Which shift could complete the most sections? It was relentless. Did you ever see a completed ship? Oh yes. They'd announce launches over the loudspeaker. Whenever a ship launched, we'd all stop working and watch. Seeing that massive vessel slide down the ways, knowing you'd contributed, even just with your little welds, was powerful. I must have watched 100 launches. Do you remember any specific ships? I remember when Robert E. Peary launched, the 4-day ship. They made a big deal about it. Newsreels, photographers, crowds watching. I probably welded sections that went into that ship, though I'd never know which ones. But it didn't matter. We were all part of it. What happened after the war? Laid off in September 1945, like most of the workers. The shipyard didn't need 90,000 people for peacetime production. I went back to being a housewife, raised my kids. My husband came home from Europe. Life went back to normal. Looking back now, 80 years later, what do you think about that experience? I think about it often. For 2.5 years, I was part of something bigger than myself. I was just one welder among thousands, doing one repetitive task. But collectively, we built 747 ships. 747 ships that carried the materials that won the war. People talk about Rosie the Riveter, women workers in factories. That was me. I was Rosie. And I helped win the war, not with guns or glory, but with welds. Good, solid, adequate welds that held for 80 years. I'm proud of that. I'm proud that I could learn a skilled trade in 2 weeks and do it well enough to contribute. I'm proud that my work mattered. And I'm proud that America had the sense to give people like me, housewives with no experience, a chance to prove what we could do. December 2024, Smithsonian National Museum of American History. A new exhibit opens. Liberty Ships, the mass production of victory. The exhibit displays artifacts from Liberty ship construction, welding equipment used at Richmond Shipyard, section models showing prefabrication assembly, training manuals from Kaiser's rapid training programs, time-lapse photography of ship construction, interactive displays showing construction timelines. But the centerpiece is a comprehensive analysis of Liberty ships' strategic impact. Exhibit text: The Arithmetic of Victory. World War II was an industrial war. Victory required moving millions of tons of supplies across oceans: ammunition, fuel, food, vehicles, equipment, replacement materials. The challenge: Germany's U-boats sank 3,500 Allied merchant ships, 1939-1945. 14.6 million tons of cargo capacity destroyed. Replacement required building 10,000-plus ton ships faster than they could be sunk. Traditional solution, inadequate. 18 months per ship. Equals 100 ships per year from all US yards. Germany sinking 700-plus ships per year. Deficit, 600 ships per year. Result, strategic failure, unsustainable losses. Liberty ship solution, 42 days per ship, equals 2,000 ships per year from 18 yards. Germany sinking 700-plus ships per year. Surplus, 1,300 ships per year. Result, strategic victory, unsustainable enemy. The difference. Mass production methodology applied to shipbuilding. Henry Kaiser's innovation wasn't better ships. It was faster ships through system redesign. Key innovations. Prefabrication. Build sections separately, assemble rapidly. Task specialization. Train workers in specific tasks, not general shipbuilding. Parallel production. Multiple sections built simultaneously. Adequate design. Optimize for producibility, not perfection. Continuous improvement. Each ship incorporated lessons from previous ships. Results. 2,710 Liberty ships built, 1941-1945. 27.1 million tons of cargo capacity added. 75% of all Allied cargo transported in Liberty ships. Strategic logistics never constrained by shipping capacity. America could afford to lose 200 ships because 2,500 remained. The lesson. Wars are won by logistics. The side that can deliver more supplies, faster, with sustainable production wins, regardless of tactical superiority. Liberty ships proved that adequate ships in overwhelming quantity defeat excellent ships in limited quantity. This principle defined Allied victory in World War II and remains fundamental to modern military doctrine. December 2024. Final reflection. Henry Kaiser died in 1967, 22 years after the war ended. His obituary in the New York Times focused on his various achievements: building the Hoover Dam, founding Kaiser Permanente Healthcare, establishing Kaiser Aluminum and Kaiser Steel. But the obituary's lead paragraph captured his essential contribution. Henry J. Kaiser, who proved that the impossible could be accomplished through industrial willpower and systematic innovation, died yesterday at age 85. He was best known for revolutionizing shipbuilding during World War II, producing 1,490 vessels through methods that experts said couldn't work, but which proved devastatingly effective. The ships Kaiser built are mostly gone now, scrapped, sunk, or converted beyond recognition. Only 2 remain operational. Jeremiah O'Brien and John W. Brown, museum ships maintained by volunteers who refuse to let the legacy die. But Kaiser's real legacy isn't the ships. It's the proof that conventional wisdom about what's possible is often just conventional wisdom about what's traditional. They said you can't build ships in less than 18 months. Kaiser built them in 42 days. They said you can't train shipbuilders in weeks. Kaiser trained 200,000 workers and produced excellent results. They said you can't use assembly line methods for shipbuilding. Kaiser proved that ships are just large manufactured products. They said you can't win a war through logistics. Kaiser proved that logistics is how wars are won. The Liberty ship program cost $2.6 billion, 1945 dollars, approximately $42 billion in 2024 dollars. For that investment, America gained 2,710 cargo ships, 27.1 million tons of cargo capacity. Strategic logistics superiority that enabled victory in 2 theaters simultaneously. Proof that American industrial capacity was unmatched. A psychological weapon, the demonstration that America could outproduce any enemy. The final arithmetic. $42 billion divided by 2,710 ships equals $15.5 million per ship. But the real calculation is $42 billion equals Allied victory in World War II. Because without Liberty ships, there is no D-Day. Without Liberty ships, there is no sustained offensive across Europe. Without Liberty ships, there is no island-hopping campaign across the Pacific. Without Liberty ships, Allied armies cannot be supplied, sustained, or supported. Liberty ships didn't win the war alone, but they made winning possible, and that's worth any price. Epilogue: The Last Liberty Ship. May 2025, San Francisco Bay. SS Jeremiah O'Brien steams under the Golden Gate Bridge, conducting her annual Living History cruise. The 82-year-old ship operates under her own power, her 1943 vintage reciprocating steam engine pounding rhythmically, pushing the vessel through calm waters at 11 knots. On deck, 500 passengers, historians, students, veteran maritime enthusiasts, experience what sailing on a Liberty ship felt like. The vibration of the engine, the smell of steam and oil, the utilitarian design where function always trumped form. Captain Ray Jennings, volunteer captain, retired merchant mariner, stands on the bridge, guiding the ship he's helped maintain for 20 years. Every time we take her out, Jennings says, I think about the workers who built her in 56 days. I think about the merchant sailors who sailed her into combat zones. I think about the cargo she carried, ammunition, fuel, supplies that kept armies fighting. This ship represents something Americans need to remember. When we decide something must be done, we figure out how to do it, even if experts say it's impossible. Liberty ships were impossible. Everyone said so. Traditional shipbuilders, naval architects, industry experts, all agreed you couldn't build proper ships in weeks using untrained workers. Henry Kaiser asked one question: why not? And when he couldn't get a good answer, he proved it could be done. The ship passes Alcatraz Island, heading west toward open ocean. In the engine room, the original 1943 engine, built by workers who learned engine assembly in 3 weeks, continues operating smoothly after 82 years and millions of miles. On the stern, visible in freshly painted white letters, SS Jeremiah O'Brien. Below that, a small plaque. Built, New England Shipbuilding, Portland, Maine. Keel laid, March 6, 1943. Launched, June 19, 1943. Construction time, 56 days. One of 2,710 Liberty ships built to last 5 years, still sailing after 82 years. Proving that adequate can be extraordinary. The ship continues west, toward the open Pacific, carrying her cargo of memories and her message of possibility. When America decides something must be done, we do it, not perfectly, but adequately, and faster than anyone believes possible. That's how wars are won. That's how the impossible becomes routine. That's the legacy of the Liberty ships.